Here's a southern hemisphere heteromorph. This is Australoceras from Australia. Comes out of the Cretaceous of Queensland. And like many heteromorphs, the coils are not touching. The coils are separate from each other. And it's always a puzzle what a selective advantage this would have had for an animal with this kind of coiling. It would seem like it would make the shell much less strong than if the coils are backed up against themselves. One of the purpose of a shell of a animal, and particularly an active animal like the ammonites were, one of the advantages of having a shell is that the shell offers protection, and you want something that's strong. You want something that will give rigidity to the animal so it can be protected. Ammonites were able to go into a variety of depths of water, to move into lower, deeper elevations of water where the pressures are more intense, and the shell offers a protecting cover. And this type of loosely coiled shell would seem to negate against that advantage of having a shell. So it's very puzzling why these animals develop these peculiar and aberrant shells. They don't seem to be of any selective advantage to the organism. They don't seem to be have offered any advantage that we know of. A couple of other late Cretaceous ammonites. This is one from Northwest Territories in Canada. Comes out of the Cretaceous. There is not a great deal of latitude variation in the Mesozoic. You find animals that you associate with rather warm waters being fossilized or found as fossils at very high latitudes. Sort of the same thing as you get with dinosaurs. As you know, there are dinosaurs found in Alaska and even Ellesmere Island and Arctic areas today that are very cold and in no way, shape, or form could support a reptile, or it would seem very difficult that even an endothermic animal like dinosaurs may have been would be able to be supported in these cold climates, at least that which exists today. We do know that during the Mesozoic, North America was farther south. The whole continent of North America has moved to the northwest throughout the Cenozoic era, and that may explain some of it, but it doesn't seem to explain it all. You find a very cosmopolitan distribution of ammonite genera, as well as other Mesozoic genera that don't seem to reflect the variation in latitude that you find characteristic of organisms today. Another peculiar ammonite at the late Cretaceous is this straight ammonite called Baculites. Baculites is a very long straight ammonite that is atypical of ammonites because they're usually coiled. Baculites is straight, although the very apex, the very terminal end of the shell is coiled. Usually that's not preserved. It's very rare to find a Baculites fossil with the end of the shell preserved. But they're very common ammonites in the Pierre shale, in the Bearpaw shale, and the late Cretaceous shales of the high plains and the intermountain basins of the Rocky Mountains. Baculites, this is a species that comes from the Gulf Coast. This is from Owl Creek again, the Ripley group in Mississippi. This is Baculites compressus, a form that is common in the Pierre shale in the western United States. Here's a cross-section of a Baculites shell showing the chambers, showing the chambers which have been filled in with a druze of calcite, but the chambers would act as a place for gas to be injected, and the animal could raise or lower itself in varying depths of water, much as does a submarine.